Hey guys, today we are going to talk about the binomial theorem, which we use when we are going to raise a binomial to a higher power, such as 5 or 7. First, we're going to distinguish the similarities and differences between multiplying 2x to the fourth power times 2x to the fourth power times 2x to the fourth power. We are going to multiply our coefficients, which would be 2 to the third power.
Drew Tyre, please come to the main office. Drew Tyre, please come to the north main office immediately. Thank you.
Well, I hope he goes to the office. And 2 to the third power.
You know you can pause, right? You can pause and go,
Shh. That's Mr. Carizzi. Say, hey, Mr. Carizzi.
what's up, Mr. Carizzi?
Hey. 2 to the third power is 8. And for x to the fourth power times x to the fourth power times x to the fourth power, we add our exponents and we get x to the 12th power. If we have 2 plus x raised to the third power, then we have 2 plus x times 2 plus x times 2 plus x. We first have to FOIL our first two binomials and then multiply that product by 2 plus x. We're not going to do that one because we are going to do x plus y. So we're going to start by expanding x plus y to the third power by first multiplying x plus y times x plus y. So we're going to use FOIL x times x squared, x times y, plus xy, y times x, plus xy, and y times y, plus y squared. All times x plus y. I need to combine like terms in my first polynomial, so I get x squared plus 2xy plus y squared. Let's put our phones away, please. Times x plus y. We now have to distribute the x and y to each term in our trinomial. So x times x squared will give us x cubed. 2xy times x will give us plus 2x squared y. And y squared times x is plus x y squared. Now for the y, we're going to multiply y times x squared, which will be x squared y. So I'm going to line it up with the like terms. Then y times 2xy will give us plus 2xy squared. And y times y squared will give us plus y cubed. Our final answer will be x cubed plus 2x squared.
Drew Tyre, please come to the north main office. Drew Tyre, please come to the north main office immediately.
3x squared y plus 3x y squared plus y cubed. That is going to be a little bit neater on our next slide. So we can notice some patterns. We have x cubed plus 3x squared y plus 3xy squared plus y cubed. So two of the patterns that we will need to expand binomials will be that the exponents of the first term in the binomial, which would be x, go from 3, starting at 3 in the first term, and down to 0, where the exponents of the second term, y, start at 0 and go up to 3. So that's the pattern that we're going to use for our exponents. Then we need to find the pattern for our coefficients of our terms. We use what's called Pascal's triangle, and Pascal's triangle starts with a triangle of 3 ones. So we have 1, 1, and 1. To then continue the triangle, we have to add the 2 ones to get our next row. There's always going to be an outside row of 1s going down the sides, and then we're adding the numbers in the row above to get the middle terms. So here we added 1 plus 1 to get 2. To get our next row, we're going to add 1 plus 2 to get 3, 2 plus 1 to get 3, and we have the 1s on the outside. I'm going to make row 5 here. So I start out with a 1, then 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1, 5, and ending with a 1. So we're going to use these numbers to be our coefficients for our terms. We use the power that we're raising our binomial to. The power that we're raising our binomial to is the row number that we use. So we just raised our x plus y to the third power. So we would be using the third row. As you can see, in our answer, our coefficients match up with the numbers in row 3. The first row is row 0, then row 1, row 2. The rows with the second number as 3 is row 3. The numbers in row 3 are 1, 3, 3, 1, and our coefficients in our answer are 1, 3, 3, and 1. When the binomial involves subtraction instead of addition, we're still going to use the same patterns, but we're going to alternate signs. So the first term will be positive, then negative, positive, negative, positive, and negative. We're going to try 1 together. We're going to do x minus 5 to the 5th power. So first, we're going to write out our coefficients. We need the 5th row of Pascal's triangle, which we found before was 1, 5, 10, 10, 5, 1. So I'm going to write out 1, 5, 10, 10, 5, 1. Moving Pascal's triangle out of our way. Alright, it just doesn't want to cooperate. Really? Okay. And 1 was our last number. Then we said our first term, which is x, is going to start at 5 and go down to 0. So we have x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and x to the 0. And our second term, y, is going to start at 0 and go up to our powers. So x to the 0, x to the y to the first, y to the second, y to the third, y to the fourth, and y to the fifth. Since we have subtraction, we're going to alternate signs, so positive, negative, positive, negative, positive, and negative. The last thing we're going to do here is get rid of y and x to the 0 power, because that is just 1. So our final answer would be x to the 5th power minus 5, x to the 4th, y, plus 10, x to the 3rd, y to the 2nd, minus 10, x squared, y to the 3rd, plus 5x y to the 4th, minus, just kidding, minus, come on, seriously, y to the 5th. That's all, folks.